Connecting land descriptions to the rectangular survey system. In the previous section, you learned how the rectangular survey system divides land into townships and sections to create a consistent national grid. That framework is especially important in Arizona, where large areas of desert, ranchland, and mountains were surveyed using that method and then later sold, leased, or reserved. Now you will build on that foundation by looking at how Arizona land is actually owned and managed, how different kinds of legal descriptions appear in practice, and how special Arizona issues such as state trust lands and earth fissures affect real estate activities. This section brings together law, history, land management, and practical description methods so you can see how an apparently simple piece of dirt in Arizona is actually part of a complex legal and physical system. Arizona land ownership and land management overview. In Arizona, every inch of land is owned by someone. There is no ownerless land. Broadly, Arizona land is divided among federal ownership, Native American tribal lands, state trust lands, and privately owned lands. Even within a single county, you may see a checkerboard of ownership patterns. A state trust section next to a tribal reservation boundary, a block of Federal Bureau of Land Management land, and a cluster of privately owned parcels in an unincorporated area. For a real estate licensee, this means that understanding who owns the land, who manages it, and what rules apply is just as important as understanding where it is located on the rectangular survey grid. Arizona State Trust Land and the State Land Department. A major portion of Arizona's land is held in state trust, rather than owned outright by the state in a general sense. When Arizona became a state in 1912, Congress granted specific sections of land in each township to be held in trust for designated beneficiaries. Today, the Arizona State Land Department manages approximately 9.2 million acres of these state trust lands. The trust concept is crucial. The state is not simply a landowner choosing how to use property. It is a trustee with legal duties to manage the land for the sole benefit of 13 named beneficiaries, the largest of which are the common schools, meaning K to 12 public education. In practical terms, this means that when the department auctions a state land parcel near Phoenix for commercial development or leases rangeland in Cochise County for grazing, the revenue generated is held and distributed to support those beneficiaries rather than being spent freely as general revenue. Authority and legal framework for state trust lands. The authority for Arizona's state trust land system comes from multiple legal sources. The Federal Enabling Act, which allowed Arizona to become a state, includes sections that grant land and impose trust obligations. The Arizona Constitution, particularly Article X, specifies how those lands must be held and managed. The Arizona Revised Statutes, especially Title 37, add detailed rules for leasing, sale, rights of way, and resource extraction. Together, these documents create a strict framework. The State Land Department is not a typical regulatory agency. It is a trustee bound by fiduciary obligations and detailed statutory procedures. For example, state trust land cannot simply be given away or sold at a discount to encourage development. The department must ensure that any sale or lease returns fair value to the trust beneficiaries. This affects developers, ranchers, utilities, and even school districts that seek rights of way or lease terms on trust lands. Trust beneficiaries and revenue flow. The beneficiaries of Arizona State Trust Land include common schools, universities, special schools, such as those for the deaf and blind, penitentiaries, charitable institutions, state hospitals, and other public institutions, such as agricultural and mechanical colleges, and certain state buildings. When the State Land Department sells a parcel in a fast-growing area like North Phoenix or Queen Creek, proceeds from that sale are generally deposited in a permanent fund managed by the Arizona State Treasurer. The principal is invested, and a portion of the earnings is distributed annually according to constitutional formulas. lease revenues, permit fees, interest on sales contracts, and other expendable revenues may flow directly to beneficiaries. For example, a grazing lease in Mojave County, a commercial lease for a cell tower in Yavapai County, and a right-of-way grant for a power line in Pinal County all generate income that ultimately supports the designated beneficiaries, especially K-12 education. Historical development of Arizona land administration. Arizona's land administration system developed over time as the territory and state evolved. Congress created the Arizona Territory in 1863, and in 1910 it adopted the Enabling Act, which laid the groundwork for statehood and the land grant system. 4 sections in each township were originally dedicated for specified purposes and required to be held in trust. In 1915, the State Land Code established the Arizona State Land Department and created the Office of the Commissioner of State Lands. Early commissioners focused on selecting trust lands, perfecting title, and beginning leases and sales to generate revenue. Over the decades, additional responsibilities were assigned and later reassigned. In the mid-20th century, water resource duties were briefly housed in the State Land Department, before being moved to the Arizona Department of Water Resources in 1980. The office also absorbed the work of a Soldier Settlement Board, which helped veterans acquire rural homesteads after World War I. Later, forestry and wildfire responsibilities were linked to the department and then spun off into what is now the Arizona Department of Forestry and Fire Management. For you as a real estate professional, the key point is that the State Land Department's central mission remains to manage trust land and its resources for the beneficiaries, while other agencies, such as ADWR and the Department of Forestry and Fire Management, handle water and wildfire policies that also affect land use. Survey methods and the Arizona Rectangular Survey. Land descriptions in Arizona rest heavily on the rectangular survey system you studied previously. The Arizona survey work dates back to the 1860s, when federal surveyors began laying out townships using a principal meridian and baseline. Arizona's main survey framework is the Gila and Salt River baseline and meridian. The meridian originally followed a line near the confluence of the Gila and Salt Rivers south of what is now Phoenix. Today, the meridian runs approximately along 115th Avenue and the baseline along Baseline Road. The point where they intersect is called the initial point, and it lies near Avondale. From that initial point, surveyors establish township lines every 6 miles north and south, and range lines every 6 miles east and west. The result is a grid of townships, each 6 miles square, and within each township, a grid of 36 1-mile square sections. In the northeast corner of Arizona, a portion of the Navajo Nation is described by a separate Navajo meridian and baseline, but most Arizona land descriptions still refer to the Gila and Salt River baseline and meridian, abbreviated G and SRBM, correction lines, checks, and fractional sections. Because the Earth is curved, surveyors in Arizona had to adjust their grid to maintain roughly uniform township sizes. They introduced correction lines every 4th township line north and south of the baseline, and guide meridians every 4th range line east and west of the principal meridian. These lines create a larger unit called a check, a 24-mile square quadrangle composed of 16 townships. As you move north from the baseline, each check is slightly offset from the one to the south. Within a township, 11 sections along the northern and western edges are often fractional rather than full sections. Other sections may be irregular, where they border rivers, lakes, or state and reservation boundaries. These irregular sections are known as government lots. In Arizona, such government lots can be found along the Colorado River, around reservoirs like Lake Powell or Lake Mead, and near certain reservation boundaries. When working with land near those edges, you will see legal descriptions that refer not only to quarter sections, but also to specific government lots with unique acreages, brass caps, datums, and air lots in Arizona, To translate map-based descriptions into physical reality, surveyors in Arizona rely on fixed markers and elevation reference points. Brass caps, sometimes called brass monuments, are metal discs set into concrete or rock across the state to mark survey control points, section corners, and elevation benchmarks. You might see one at a road intersection in an older part of Phoenix or near a rural highway in Coconino County. These caps allow surveyors to confirm boundary lines and elevations. When brass caps are not available, surveyors may refer to local or national datums, which are reference levels for elevation. In Arizona, one well-known local reference point is the Arizona Divide near Belmont, which separates drainage flowing generally north from drainage flowing generally south. For vertical descriptions, a datum allows surveyors to define air lots and subsurface rights. For example, an upper floor condominium in downtown Phoenix may be described legally as occupying a space between two specified elevations above a datum, while subsurface tunnel or utility easements may be described as lying a certain number of feet below the same reference. Multiple legal description methods on a single parcel. Because Arizona contains both large rural tracts and densely platted subdivisions, it is common to see more than one legal description method used for a single parcel. A ranch property might be described by rectangular survey fractions, such as the east half of the northwest quarter of Section 10, then further refined with a meets and bounds description to describe an irregular fenced area or exclude a small portion previously sold. A subdivision lot may be primarily described using the lot and block system, but the plat itself will reference the underlying section, township, and range. Generally, the more remote or irregular the parcel, the longer and more complex its description. When you read a deed that runs for several paragraphs with a mix of meets and bounds calls and section fractions, it is a signal that the parcel is in a less developed area and has a long history of piecemeal carving out of larger tracts. The government survey system in practical Arizona use. A government survey description in Arizona will usually include quarter and half designations, a section number, a township designation indicating how many townships north or south of the baseline, a range designation indicating how many ranges east or west of the principal meridian, and the G and SR BM reference. For example, a 10-acre parcel might be described as the southeast quarter of the northeast quarter of the southwest quarter of Section 1, Township 1 North, Range 1 east of the Gila and Salt River baseline and meridian. In shorthand, this may appear as SE4, NE4, SW4 of Section 1, T1N, R1E, G and SRBM. When you read NW4, SE4, you say the northwest quarter of the southeast quarter. A comma between fractional designations is read as of the, while a semicolon separates distinct parcels within the same section. For example, SW4, E2, W2, NE4, Section 23 means the southwest quarter of the east half of the west half of Section 23 and the northeast quarter of Section 23. When parcels lie in different sections, the word and separates them, such as NE4, Section 31, and NW4, SE4, N2, Section 2, which describes three separate parcels in two different sections. The lot and block system in Arizona subdivisions. For smaller properties, such as individual homes, commercial pads, and condominium projects, the lot and block system is far more efficient than a long rectangular survey description. In this system, a surveyor creates a detailed subdivision plat that divides a larger tract into lots, blocks, and sometimes tracts reserved for open space or utilities. The plat is approved by the local jurisdiction and recorded. A legal description then might read, Lot 24, Block 4, High Country Estates, Mojave County, Arizona, according to the plat of said subdivision on file and of record in the office of the county recorder of Mojave County. Behind that simple description lies a map showing exact lot dimensions and the subdivision's location within a particular section, township, and range. Arizona law requires subdividers to file plats and obtain approvals, and the Arizona Department of Real Estate oversees subdivision public reports. The lot and block description is what everyday buyers and sellers see, but as a licensee, you must recognize that it lives inside the larger framework of township and section descriptions. Parcel size and acreage calculations in Arizona. Because sections, halves, and quarters are used frequently in Arizona land transactions, you must be comfortable converting fractional descriptions into acreages. Remember that one section contains 640 acres. A half section contains 320 acres. A quarter section contains 160 acres. A quarter of a quarter, such as the northeast quarter of the northeast quarter, contains 40 acres. A quarter of a quarter of a quarter contains 10 acres. To convert any description to a parcel size, multiply the denominators of all the section fractions and divide 640 by the result. In the earlier example, NW4, SE4 means the northwest quarter of the southeast quarter. The denominators are 4 and 4 times 4 equals 16. Dividing 640 by 16 yields 40 acres. In the description, SW4, E2, W2, NE4, Section 23. The southwest quarter of the east half of the west half has denominators 4, 2, and 2. So 4 times 2 times 2 equals 16, and 640 divided by 16 yields 40 acres for that first piece. The northeast quarter, NE4, has a denominator of 4, and 640 divided by 4 equals 160 acres. Together, the total acreage described in Section 23 is 200 acres. In the final example, NE4, Section 31, and NW4, SE4, and N2, Section 2, the northeast quarter of Section 31 contains 160 acres. The northwest quarter of the southeast quarter in Section 2 has denominators 4 and 4, so it contains 40 acres. The north half of Section 2 has denominator 2, so it contains 320 acres. Adding 160, 40, and 320 yields 520 acres total. Researching who owns land in Arizona. Before working with a parcel, especially in an unincorporated area, it is good practice to understand who owns the land and what type of jurisdiction applies. County assessors maintain parcel maps and ownership records for private land and often show whether neighboring parcels are federally owned, tribal, or state trust. The state land department provides information on trust parcels, and tribal governments manage their own lands. Federal land may be under the jurisdiction of agencies such as the Bureau of Land Management or the U.S. Forest Service. Online mapping tools can indicate whether an area lies within a city, town, or unincorporated county jurisdiction. For a licensee, knowing whether a parcel is in an unincorporated area can affect zoning, permitting, and disclosure obligations. It also helps you explain to a buyer why a seemingly empty area is in fact governed by specific rules tied to its ownership category: earth fissures, ground subsidence, and Arizona land. Land descriptions do not only identify where a property is located, they also connect to what is happening below and above the surface. In Arizona, earth fissures and ground subsidence are significant land-related hazards. Earth fissures are surface cracks that can be up to 2 miles long, up to 15 to 25 feet wide, and tens of feet deep at the visible surface, with actual depths likely extending to the groundwater table. They form in certain arid valleys as a result of land subsidence driven by extensive groundwater withdrawal. As aquifers are pumped and the supporting water is removed, fine-grained sediments compact and the land can settle unevenly. This differential subsidence can cause the crust to crack, forming fissures. These features have been mapped in multiple counties, including Maricopa, Pinal, Pima, Cochise, and La Paz. Some of the first documented fissures appeared near Eloy in the late 1920s, and since then, the number and extent of fissures have increased as groundwater pumping and development have expanded. Mapping earth fissures and their impacts. The Arizona Geological Survey, charged by statute with mapping and monitoring earth fissures, has identified numerous study areas covering hundreds of square miles. Using historical reports, aerial photography, subsidence data, and field mapping with high-precision GPS, geologists document known fissures and publish maps showing continuous fissures, discontinuous segments, and reported but unconfirmed features. These maps are updated as new fissures are found or existing ones change. Even so, fissures are not static. They can widen, deepen, or extend after heavy monsoon rains or continued subsidence. Some areas investigated show no surface evidence and are left blank on maps, but that does not guarantee that fissures will never appear in the future. The impacts of fissures can be costly. They may crack or collapse roads, damage irrigation canals, harm pipelines and other utilities, crack building foundations, damage well casings, and injure or kill livestock. Mitigation efforts during construction, such as installing liners beneath highway segments or canals, can cost hundreds of thousands of dollars. Fissures can also act as conduits for surface contaminants to reach groundwater more quickly, creating additional environmental and public health concerns. Earth fissures and real estate risk management. For Arizona real estate licensees, earth fissures underscore the importance of due diligence. When listing or selling property in known fissure study areas, it is prudent to consult current fissure maps, review local government information, and recommend that buyers obtain appropriate inspections or engineering evaluations. A parcel's legal description might place it in a township and section that overlap a fissure study area. Even if the fissure does not physically cross the parcel, proximity may affect perceived value, insurance, or lender requirements. For large developments, engineers will typically review fissure data as part of planning. When individual buyers are looking at rural land in Pinal or Maricopa County, however, they may rely heavily on their agent to alert them that fissures are an issue they should investigate. Understanding that fissures are linked to groundwater withdrawal and that they change over time helps you explain why maps are important but not absolutely definitive, and why ongoing monitoring and proper disclosures matter. Review summary. In this section, you learn that Arizona land descriptions are not just technical language on paper. They reflect a larger system of ownership, trust responsibilities, survey methods, and physical land conditions. You examined how Arizona land is divided among federal, tribal, state trust, and private owners, and how the Arizona State Land Department, acting under the Enabling Act, the Arizona Constitution, and state statutes, manages approximately 9.2 million acres of trust land for the benefit of 13 named beneficiaries, especially K-12 schools. You saw how revenues from leases and sales flow into a permanent fund and as expendable income to those beneficiaries under constitutional formulas. You reviewed how Arizona's rectangular survey system, based on the Gila and Salt River baseline and meridian, and, in the Northeast, the Navajo meridian and baseline, divides land into townships and sections, with correction lines, guide meridians, and fractional sections that accommodate the Earth's curvature and irregular boundaries. You saw that brass caps and datums tie map-based descriptions to actual ground locations and elevations, including airlots and subsurface rights. You learned that Arizona commonly uses multiple description methods on a single parcel, combining rectangular survey fractions with meets and bounds and lot and block descriptions. You practiced interpreting shorthand descriptions, using quarters and halves, and calculating acreages using the 640-acre section as a base. Finally, you explored how land descriptions intersect with natural and human-induced hazards in Arizona, particularly earth fissures, caused by groundwater withdrawal and land subsidence. You saw how fissures are mapped, how they affect people, property, and infrastructure, and why the Arizona Geological Survey's mapping program and educational outreach are important. As a real estate professional, understanding these systems prepares you to read legal descriptions accurately, explain ownership and management structures, and recognize when physical hazards may affect land value and risk. Discussion. Why is it important for Arizona licensees to understand that state trust land is held in a legal trust rather than simply owned by the state? Suggested answer. Because trust land must be managed for specific beneficiaries under strict legal rules, it cannot be handled like ordinary state-owned property. The State Land Department must obtain fair value for leases and sales and follow detailed procedures. This affects how developers, ranchers, and others interact with the department and means that licensees must understand that special rules apply to trust land auctions, leases, and rights of way. Knowing this helps licensees give accurate information and avoid promising outcomes that are not legally permitted. A buyer is looking at rural land in Pinal County and asks why the legal description is so long, using multiple quarters, halves, and meets and bounds calls. How would you respond? Suggested answer. You can explain that in much of rural Arizona, parcels originated as parts of larger sections in the rectangular survey system. Over time, pieces were sold, split, or combined, often using meets and bounds descriptions to follow fences, washes, or roads. As a result, today's parcel may have a legal description that includes both section fractions and detailed meets and bounds calls. The length of the description does not necessarily mean a problem. It simply reflects the parcel's history and location in a less platted, more rural area. How do earth fissures illustrate the connection between physical land conditions and the legal concept of land descriptions? Suggested answer. Earth fissures show that legal descriptions, although abstract, correspond to real ground that can change over time. A parcel described by section fractions and lot numbers may lie in a valley where groundwater withdrawal has caused subsidence and fissuring. Those physical changes can threaten structures, utilities, and even people on that land. Because fissures are mapped by section and township, a licensee who understands land descriptions can use those tools to identify whether a parcel lies within a fissure study area and advise clients to investigate further. This reinforces that land descriptions are not just theory, they are tools for managing real-world risk. Closing remarks. Land descriptions in Arizona weave together legal authority, survey science, public policy, and physical geography. The rectangular survey system gives the state a consistent grid. State trust land rules define how large portions of that grid must be managed. Lot and block descriptions make individual parcels in subdivisions easy to identify, while meets and bounds refine irregular shapes in rural areas. At the same time, features like earth fissures and subsidence remind us that land is not static. It responds to natural processes and human use. As a real estate professional, your job is not to become a surveyor or geologist, but to understand enough about these systems to read legal descriptions thoughtfully, recognize when special ownership or hazard issues may be present, and guide your clients toward appropriate due diligence and professional advice. This knowledge will support your work in later topics, such as water law, environmental disclosures, subdivision regulation, and land development.